perfect square trinomial is when we have like standard form and it factors out to something times itself. So that would be like, for example, x plus 1 times x plus 1 would make a perfect square trinomial. The goal, because we have a perfect square trinomial, is to get it in a vertex form, which would be written as x plus 1 squared. So that's just a little example of what we're going for here. So if I have x squared plus 4x and I want to make that into a perfect square trinomial, I need to add on a c term. I don't know what that c term is going to be quite yet, but this is how I'm going to figure it out. I'm going to first take a look at that first term, x squared. Well, what makes x squared? It's x times x. X times x gets us x squared. And then I'm going to think of, okay, how do I fill in this gap right here? How do I get to a 4x? Well, I know that I'm going to need to add the same thing to itself. So to think about 4x, half of 4x is 2x and 2x. So each one of these little sections is 2x and 2x. Okay, each line is an x. So how do I get that? Well, I need to multiply x times 2 to get 2x here. And I need to multiply x times 2 here to get 2x over there. That's adding up to my middle term. Now I need the c term. So I'm trying to figure out what goes right in here to complete that square. And it's literally like, we're multiplying in a grid. If I have 2 times 2, what completes my square would be a 4. Does that make sense? How I got that? Kind of? No? Okay. If it doesn't make sense to you, then don't worry about it. We're going to learn other methods. So, what completes that square is a 4. I'm going to rewrite this as x squared plus 4x plus 4. And now what I have right here is my perfect square trinomial. Don't forget, we also have an equals 5 on the right side. Now, I can't just add 4 to my equation. That would be changing its value, and I can't do that. So I have to balance it out. The way that we're going to do that is if I add 4 to the left side, I also have to add 4 to the right side. So I'm going to have a 5 plus 4 there. And that's completing the square, essentially. That whole perfect square trinomial, x squared plus 4x plus 4. If you think about factoring that now, it should factor out really, really nicely. Things that multiply to 4 and add to 4 are 2 and 2. So my perfect square is going to be written as x plus 2 and x plus 2 equals 9. And our goal is to write this to look like vertex form. So we're going to combine that into x plus 2 squared equals 9. This is the beginnings of vertex form. If I wanted it to actually be in vertex form, I would just move that 9 to the correct side. But I want to solve this to get my x-intercepts. To get my x-intercepts, I would square root both sides. To get x plus 2 equals plus or minus 3. X equals negative 2 plus or minus 3. And I have two solutions. X equals 1 and x equals negative 5. Written as coordinate pairs. 1, 0, negative 5, 0. Kind of weird. Are we okay with that right now? Let's take a look at number 2. Again, I'm taking a look at this first number, x squared. I know x squared is going to be x times x. And to get 14, I want to add the same number twice. So I'm thinking, okay, what's half of 14? That's going to be a 7. And a 7, making 7x and 7x. Right? 7x plus 7x is 14. So what completes this square? What would have to go in this box in order to make it nice and square? we're thinking about multiplying, right? X times 7 is 7x. 7 times 7 is 49. 49 completes my perfect square, so I can think of this as x squared plus 14x. I'm going to add that 49 equals 15. And then what I do to one side, I need to remain balanced on the other. That whole right side becomes, we can actually get it from looking right here, right? X plus 7 times x plus 7. I do not have to write out the factoring step every time. If you can look at this without factoring the whole thing out and know that this becomes x plus 7 squared, then do that. Equals 64. Again, here's my vertex form. All I have to do to get it into actual vertex form is move that 64 over to the right, over to the left, and I'm good to go. To solve this, we're square rooting. X plus 7 equals plus or minus 8. X equals negative 7 plus or minus 8. And x equals 1 and negative 15. Just like that. So far, so good? Now, some of you really hate these boxes. Some of you like the boxes. That's okay. I'm going to show you a shortcut so that we don't have to draw the boxes every time. To get that magic number that we're adding to both sides every single time, we have a real nice, easy formula. The formula is we take our b value, which in this case is negative 6. We're going to divide that number by 2 and square it. That is going to get us our magic number that completes the square. So in this example, x squared minus 6x equals 16. I'm going to take that negative 6, divide it by 2, and then square it. The magic number that I get, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. 9 is the magic number that completes my square. Does that make a little bit more sense than the boxes? All right, so we take our equation now, x squared minus 6x. I need to add 9 to complete that square. Then I have the equals 16. And remember, what I do to one side, I also need to do to the other to keep it balanced. So I'm adding 9 to both sides. What does that the left side, what does that perfect square trinomial factor out to? Any ideas? Dahlia? Perfect. Any questions how we got that? If it doesn't click right away, just factor it. Just factor it normally, and that's okay. All right, then we solve by square roots. Again, if we wanted to get that into vertex form, we would just move that 25 over to the correct side. This is x minus 3 equals plus or minus 5. X equals 3 plus or minus 5. We have two answers. X equals 8 and x equals negative 2, written as coordinates. All good so far. I got a bunch more. Okay, same deal. This is what I'm trying to turn into a perfect square. This is what your equations will normally look like. They're in standard form. Everything is on one side of the equation. When I'm trying to get it into vertex form, I can leave it all on one side of the equation. Things are a little bit different, though, when we leave it all on one side of the equation. So you can either move that 15 over to the left side or over to the right side and just take care of it later, make sure your equation is balanced, or we can balance it all on the same side. Kind of depends what your goal is. Is your goal to find the x-intercepts, or is your goal to get it into vertex form? The same thing applies. We're going to take our formula here with our b value. Negative 8 over 2 squared is 16. 16 is my magic number here. I'm going to add it to my x squared minus 8x to complete that square. But that 15 is hanging out on the same side. And I want it in vertex form, so I don't want to move it. I don't want to make more work for myself. So if I'm trying to balance it on the same side, basically what I want is to pretend like I'm adding nothing. I do not want to change the value of my equation at all. So previously, we added the same thing to both sides. That's like adding 0. If it's on the same side, though, if I want to add 0, plus 16 is canceled out by a minus 16. This only happens if you're working on the same side of the equation. If you had moved that 15 over previously, you would do it the same way you did before. The intention here is just to keep everything on the left side. The whole thing in red, that's my perfect square trinomial, that is going to factor out to be x minus 4 squared. And then what's left over here is 15 minus 16, a negative 1. This was my goal to get vertex form. So maybe a little bit less work because we don't have to move the 15 over and then move it back over later. Kept it all on one side. Now that it's in vertex form, I can do all my graphing and stuff with that. And then let's say it also says find the x-intercepts. When we find the x-intercepts, we go back to solving by square roots. And in order to solve by square roots, we're moving it back to the other side. Which it feels silly, but to solve by square roots, we get everything by itself. Oops. So this is 4 plus or minus 1, 4 plus 1, 4 minus 1, 5, and 3. Questions on that? Am I being too fast? You got it? Oh gosh, we're making faces. Okay, let's do it again. So you see how everything's already on the left side? That's perfect for vertex form because in vertex form, everything is on the left side. So I don't want to make more work for myself. I'm going to keep it all on the left side. I'm going to find my magic number here by taking b over 2 squared, which is 4. I'm going to add it to make my perfect square trinomial. And then I have this minus 21 over here. Well, to balance out that I added 4, I want to cancel that out by also subtracting 4. That perfect square trinomial, x squared plus 4x plus 4, we could factor it out, or we could say, hey, I know that is plus 2 squared. And I have minus 25. Again, there's vertex form. I didn't have to move anything from left to right. I saved myself a couple steps, but now I'm going to go ahead and solve by square roots, so I'm going to put it on the other side anyways. X plus 2 squared equals 25. This is x plus 2 equals plus or minus 5. X equals 2, negative 2 plus or minus 5. 2 answers. Negative 2 plus 5 is 3. Negative 2 minus 5, negative 7. Questions there? Let me really quickly make a little side note here. If you get x plus whatever, let's say it's x plus 2 squared equals a negative 25. This is just a thought bubble over here. This is not what we have. If you ever get a negative, this is isolated and this is negative, that means you have no solution, which will still graph. You can still graph it. It's just never going to touch the x-axis. You're not going to be able to solve it with square roots. So I think you might see one of those on your homework today. Okay, so then let's look at what those graphs look like. Because what's the point of doing vertex form if we're not going to graph it? Again, we're starting in standard form. So x squared plus 2x minus 1 is standard form. And in order to do all the fancy graphing things we've been talking about, I need to get it into vertex form by completing the square. So step 1, I'm going to figure out what's my magic number here. I take my b value, divide it by 2, and square it. That is 1. I'm going to have 0 equals x squared plus 2x. I'm going to add 1. I have the existing minus 1. I'm going to balance out this plus 1 by subtracting 1. So those two things balance each other out. Here's my perfect square. We rewrite that as 0 equals x squared plus 2x plus 1 becomes x plus 1 squared minus 2. Boom, vertex form. Any questions on how we got to vertex form? Beautiful. What is the vertex? Now that I have it in this form, I can pull out my vertex. What is it? Think back to a couple lessons ago when we did this. Caitlin? Perfect. I look at my h value. I look at my k value. My vertex is at hk. So h is -1, k is -2. Beautiful. Axis of symmetry. X equals h. Do not forget the x equals part. H is -1, so my axis of symmetry, x equals -1. Let's first graph those, -1, -2. Oh, I did not want a highlighter there. -1, -2. And then my axis of symmetry will go right through it. So far, so good? Use the axis of symmetry to find 2 other points. So this means I'm creating a table of values. I'm going to start with my vertex, which I know is at -1, -2. And I'm going to pick 2 points on the same side. So I personally would go with 0 and 1 here. In order to find my y values, I'm going to take either my original or my vertex form is fine. X plus 1 squared minus 2 is pretty easy. So let's do x plus 1 squared minus 2, x plus 1 squared minus 2, and simplify. This is a -1, and that is 2. And plot here and here. Now, we want to be careful that we know which way our graph should go, so always double check your concavity. If I'm looking at standard form or vertex form, I see that my a value is positive, so I know this should be concave up. So when you're drawing this, just double check, because I see it a lot of the times where we forget. So let's make sure that we flip these points over. It looks concave up. We draw my graph concave up. That's pretty much it. On your homework, you're going to be asked to find the x-intercepts. We kind of estimated what they're going to be here because we didn't have any points, so we're on that x-axis. If you wanted to find the exact values, you would solve this by by square roots. I would add 2, I would square root, so you'd have like -1 plus or minus. Why don't we just do it really quickly? So if I wanted to find the x-intercepts, which is not part of this, I would do x plus 1 squared equals 2, square root both sides, x plus 1 equals plus or minus the square root of 2, x equals -1 plus or minus the square root of 2. So our x-intercepts here would be like -1 minus the square root of 2 and -1 plus the square root of 2. And I'm pointing this out because it does show up on your booklets. When it says find the x-intercepts and graph it, you got to do all of those things. Any questions on that? I'm going to do one more because a weird thing happens on one of the problems in your booklet for sure. So I'm going to change this problem. And instead of doing, it's pretty much the same. I'm just going to put what's it called? A leading coefficient in here. I'm going to make my leading coefficient a -2. So now my equation is -2x squared plus 4x plus 12. If I were to factor this, my initial gut reaction would be to take out a GCF. And that's exactly what we're going to do here with completing the square. So let's first take that out. My GCF in this problem would be that -2. And I'm left with x squared, x squared minus 2x minus 6. You have a problem like this in your booklet, so make sure you're taking some notes here. I'm still trying to complete the square. My square is just now inside these parentheses. This is what I'm trying to complete. So I still use my same formula. I take that b value. B over 2 squared is -2 over 2 squared. -1 squared is 1. So I'm still adding that 1 in order to make my square completed. So let's add 1 here. I have that existing -6. I want to balance it out by doing a -1. Everybody with me so far? Let's rewrite this part and this part. So I'm going to have 0 equals, actually, let's leave that part for right now. X squared minus 2x plus 1. That's going to be my perfect square part. And then the -6 minus 1, that's going to be the extra stuff. That's the -7 that's on there. If we think about the parts of our vertex form, we know that this is going to become our h value, and this -7 should be our k value, but currently it's stuck inside those parentheses. If you think about what vertex form looks like, a times x minus h squared plus k, k cannot be inside the parentheses. So we need to get that -7 out. To get the -7 out, we have to pay attention to this -2 in the front. We cannot rewrite this, and I'm going to put an angry face over here. I do not want to see you make the mistake of writing this as -2x minus 1 squared minus 7. It is not a -7. It is a -7 times a -2. So when I finally rewrite this in its final answer form, x minus 1 squared, I'm multiplying -7 times -2 to get a plus 14. That's just a weird thing that happens when I have a leading coefficient. In order to take it out of these parentheses, because it's being multiplied by a -2, I have to take out the -2 and the -7 to make a positive 14. Does that make sense? We can finish this off by graphing it. That -2 becomes like our a value, so that's telling me that my graph is going to get skinny. And I can also figure out my vertex. Vertex is at 114. Axis of symmetry is x equals 1. Table of x and y values. My vertex goes in first, 114. I'm going to pick 2 points. I personally would pick 0 and -1, but I think last class picked 2 and 3, so let's just go with that. -2 times 2 minus 1 squared plus 14. -2 times 3 minus 1 squared plus 14. This is going to be 2 minus 1 is 1. 1 squared is 1. 1 times -2, -2. This is 12. And then I think this is 6. So we plot 1, 14. I have 2, 12. And I have 3, 6. Again, double check your concavity. I have a -2 in the front here, so I know this is going to be concave down. So as I flip my points over They should look concave down, and if they don't, you did something wrong. Okay, we made it through. Any questions?